Hey guys, this is Integrated Math 3 Notes number 2 for Unit 1. Go ahead and write down the FLT here and then press play whenever you're ready. Okay. Given an expression, students will be able to multiply polynomials by applying distribution or the area model. So again, this is a review, but again, don't worry if you're learning this for the first time. Okay. So previously, we learned how to add and subtract polynomials. We even learned how to classify them in the last lesson. So now we want to know, well, what happens if we have to multiply polynomials together, right? So you guys are learning all of these little techniques to get to a bigger picture, okay? To learn how functions behave. So this is just something that you have to get past so that you can start understanding how functions behave better later, okay? So your goal for today is knowing how to multiply polynomials, either by distribution or the area model, which I'll show you both, okay? So just recall back in elementary school, way back in the day, they'll ask you, well, how many squares are there, right? Okay, and it's not one of those think outside the box kind of questions. It's literally how many squares are there. And when you first learned to count, you would count it one at a time. You would count it one at a time, and then eventually you get to 20. There are 20 squares, right? And then you learned that there's a faster way of doing it. Well, I noticed that there are 4 squares going down this way, and then there are 5 squares going over this way. So the faster way to add something repeatedly is to multiply. You find out that this is really just 4 times 5. Okay, that'll get you the area, or the number of squares that you have here. So that was like your shortcut. When you guys are multiplying polynomials, it's the same thing, except you're dealing with variables, right? Which is the only thing that kind of throws it off, okay? So just keep that in mind. Here we go. Here's example 1. Go ahead and write it down. Play when you're ready. So here I'm going to show you 2 different ways, and I'll let you decide which way is better for you. Now, I'll say right here, some people might see this and they might think of the phrase FOIL. And although it does work, it doesn't always work, which is why I'm not a fan of it, okay? If you've never heard of FOIL, great. Okay, if you have heard of FOIL, make sure you unlearn it, okay? So here's what you do. The first way is the distribution way. Okay, so you draw a bunch of arrows, okay? So the first number will multiply to everything in the second quantity here, okay? And then the second number will multiply to everything in that second quantity. So there's going to be 4 parts of multiplication here, okay? So we'll do it one at a time. Here we go. Uh-oh. Okay, here we go. So x times x, when you're multiplying it by itself, x times x is x squared. Okay, then x times a positive 4 is a positive 4x. Let's keep going. Positive 3 times x is a positive 3x. And positive 3 times positive 4 is a positive 12. Okay? You noticed back in that last lesson, there's actually 2 terms that you could put together here. You could combine it. 4x and 3x makes 7x's. And then you bring everything else down because they have nothing else to combine. You end up with this quadratic trinomial. Okay? So that's what most of you guys will see. Again, I discourage FOIL, and I'll tell you before this lesson ends on why it doesn't work, okay? Always. The other way is, remember, when you're multiplying two things together, x plus 3 times x plus 4, it's like you're counting all of those squares quickly again. When you're multiplying, you're really finding the area, right? So what's really happening here is you can create an area model. So here I have an x and a plus 3, so I'm going to write an x and a positive 3. All right. Now we're multiplying that with an x plus 4, so I'll put a x plus 4 here. Okay, you guys have seen this a lot, even in biology with Punnett squares. So here in this square, you're multiplying x times x, which is x squared. Okay. Over here, you're multiplying. Actually, let me draw some arrows. Over here, you're multiplying x times the 3, which is 3x. I'll put a positive 3x there. I'll get rid of the arrows. Okay. Now, here, you're multiplying x times the positive 4. That's a positive 4x. And lastly, positive 4 times positive 3 is a positive 12. Okay. So that's an organized way of multiplying it out. I noticed that these two are like terms, so I can put those together. That becomes a positive 7x. And anything that wasn't touched, I'll bring down. X squared plus 7x plus 12. And notice how we get the same answer here, okay? There's definitely benefits to either method, okay? So this right here is called the area model. And that's basically it. So you want to decide which way is better for you. There's no wrong way of doing it. It's just based on preference. Some people like organization with the squares. Some people like just drawing arrows because they can keep track of it. It's really just up to you there, okay? All right. For part B here, I want you to go ahead and do it both ways, just for this one problem, okay? So play whenever you're ready. Okay, so by distribution, x times x is x squared. X times positive 7 is positive 7x. Positive 2 times x is positive 2x. And positive 2 times positive 7 is positive 14. I noticed that the two terms right here can be combined. That becomes x squared plus the 9x plus the 14. That's the distribution model, okay? Area model, you would set up as x plus 2 and x plus 7. If you guys had those flipped around, it would still be the same because remember, multiplication is commutative, meaning the order really doesn't matter. 2 times 5 is the same thing as 5 times 2, okay? So if you multiply this out for each box, you should get x squared here, a positive 2x, a positive 7x, and a positive 14. You notice that you have two common terms, so x squared plus the 9x plus the 14. Hopefully you got that right. Okay, and hopefully now you have a preference. Okay, here's part C. Play whenever you're ready, but now go ahead and just choose which way you would like to do it. You don't have to do it both ways here, okay? And then play when you're ready. Okay, so whether you're distributing or the area model, you should get, here I'll use the distribution model, 2x times 4x is 8x squares because 2 times 4 is 8, and x times x is x squared. 2x times the 5 is a positive 10x. Positive 3 times the 4x is a positive 12x. And positive 3 times 5 is a positive 15. Okay, if you did the area model, you should have gotten those 4 terms anyways, okay? Okay, so we can combine like terms here. So that's 8x squared plus 22x plus 15. Oh, that was weird. Okay. Again, text me, replay it if you don't get it, but text me if you have questions, okay? Here, part D, watch out for these negatives. Pause and play whenever you're ready. So here I'll use the area model, 5x minus 1, 2x minus 3. So if I multiply the first box, I should get 10x squared, negative 2x, negative 15x, and negative 3 times negative 1 is positive 3. So you got to practice with your negatives. You don't want to get thrown off by that, okay? So I noticed that these two linear terms right here in this case can be combined. Negative 15x plus a negative 2x, same signs we're going to add. That becomes negative 17x's. I have a 10x squared, and I have a positive 3. Okay? Again, replay it or text me if you have questions, okay? Now, here's example 2. This one's a little bit different because now you have a binomial multiplied with a trinomial. Okay? Most people like to use the area model because there's a lot going on. But that doesn't mean you can't use the distribution model, okay? Distribution model, you would just have to be super organized. You would have to, I'll show you the arrows here. You would have to multiply the x times everything in the other quantity. And then you would have to multiply the 3 to everything in the other quantity. So you're actually going to get 6 different answers. Okay, or 6 different products, I should say. But here I'll show you the area model. It's up to you on how you want to do this. I have an x plus a 3. But here I have an x squared. I have a positive 3x, and I have a positive 5. So I'm going to have to cut this up into there. Okay, so notice how we have 6 squares, which is why we have 6 products. Okay. So x squared times x is x to the 3rd power, because x times x times x is x cubed. 3x times x is a positive 3. X times x is just x squared. And positive 5 times x is just positive 5x, okay? Positive 3 times x squared is just positive 3x squared. Positive 3 times positive 3x is positive 9x. And positive 3 times positive 5 is positive 15. And I know I'm going a little bit fast, but I'm just trying to make the video short. Feel free to play and replay if you need to, okay? You'll notice here that when you set up an area model, your diagonals are actually like terms. See how both of those have the same x squares? And then separately, these are both linear. So the diagonals tend to just combine itself here. So we'll go in order. We have an x cubed that's by itself. If I look at the blue highlight, how many x squares do I have there? I have 3 plus another 3, which makes a positive 6x squared. Okay, and if I look at the orange here, how many x's do I have? I have 14 of those x's. And then I have that lonely 15 constant. And that's it. I have a cubic polynomial here. Okay? All right, here's one for you guys to try. And then play when you're ready. Here I'm going to use distribution. So x times 2x squared is 2x cubed. That's going to be 2x squared. And that's going to be plus 1x. You can put x if you want to. 2 times 2x squared is going to be 4x squared. Now take a look at what I do here. I put it right where the x squares are, okay? Positive 2 times 2x is going to be a positive 4x. And positive 2 times a 1 is a positive 2. Okay? Because I lined everything up, it's really easy to see. I'm going to have 2x cubed here plus 6x squares plus 5x's plus the 2. All right. Play and replay if you need to. Here's the last one. I'll use the area model here. Play whenever you're ready. Okay. You should get x cubed, negative 4x squared, negative 3x, negative 1x squared, positive 4x, positive 3. Okay, I noticed that my diagonals I can combine. Notice how they're the same term. Okay, so I'm left with x cubed minus 5x squared plus 1x plus the 3. Okay, if you got that, great. If not and you're not sure, text me, okay? I'll be there to support you. Here's the last example, you guys, for the day. Sometimes they'll write it in a very peculiar way. You guys have seen this before. Think about what a square means, okay? A square is really just multiplying the same thing times itself. And that's the only thing that's different, okay? When you square something, you're multiplying it by itself, and then you continue on. So whether you want to do distribution or the area model, it's up to you, but go ahead and play when you're ready. This should come out to x squared plus 4x plus 4x plus 16, which gives you x squared plus 8x plus 16. Okay? Okay, I don't expect you to go at my speed, so make sure that you just go at your own pace and make sure you understand it, okay? Here's one for you to try. Eventually, you should get x squared plus 12x plus 36. Okay, if you didn't get that, go back and check your work. I do want you guys to show your work. Don't skip any steps here, okay? When we get to it, I will show you where we can cut corners, but right now is not the right time, okay? Okay, now the last one here, you have a cubic. That just means you're multiplying it by itself how many times, right? So it should be 3 different times. So here's what you do. If you take care of these two, okay? Whether you use the area model or if you use distribution, I'll use distribution here. You should get x squared plus 2x plus 2x plus 4. So this becomes x squared plus 4x plus 4. And I'm going to go ahead and group that, okay? Now remember this lonely x plus 2 factor that was left alone. I'm going to bring that down. Okay, so now you have to just go one step further here. And right here, I'll use the area model. Okay, I have an x squared plus a 4x plus a 4. And then I have a x plus a 2. So that's just x cubed, 4x squared, 4x, I should put plus signs here, plus 2x squared, plus 8x, plus the 8. I noticed that I have diagonals that I can combine. Okay, so that's going to be x cubed plus 6x squared plus the 12x plus the 8. Again, I don't expect you to move at my speed, so go at your own pace and ask a lot of questions, okay? That's pretty much it for today. Yeah, if you have any questions, let me know, okay?